Hello AP Physics students, Dr. Berenzi here, and I wanted to give a little background video on how trig functions transform, especially since we were talking about how we came up with things like amplitude and angular frequency and phase shift and all that, and I want you to get a better graphical understanding. I guess I had assumed that you had some of that in pre-calc. But maybe we need to brush up on this a little bit. So I want you to make a connection between how this cosine function changes and some of the variables that I introduced to you about simple harmonic motion, or some of the properties of simple harmonic motion. Okay, so this is a cosine function. It's our good old-fashioned y equals cosine of t, and t is the time axis here, horizontal, and we're going to let y represent our displacement, so this might be an up and down displacement instead of left or right like I showed you in class, but it's the same principle. And what we know about this cosine function is that it repeats itself. It has a period of 2 pi. So every 2 pi it will actually repeat itself. Now in math that's okay to talk about t in terms of pi, but in physics we really like to use things like t representing a whole second or half of a second or a fifth of a second. So what we really would want instead is some cosine function that we could write to say that, for example, something that repeats itself every 3 seconds, or something that repeats itself every 5 seconds. In other words, we'd like the period to be 2 seconds, or the period to be 5 seconds. And what we can use is we can use this formula over here that we learned in class, is that the angular frequency, omega, is equal to 2 pi over the period, and this omega, this angular frequency, is what you multiply times time. So this is omega times t here. So if I were to plot this function, y equals cosine of 2 pi over 3 times t, what I should get is I should get a cosine function that will repeat itself once every 3 seconds, because after all t is 3, instead of getting something that repeats every 2 pi like this one does. So let's plot that and actually see if that's the case. So this blue curve is what 2 pi over 3 times t looks like, or cosine of that. And let's actually see if it does repeat itself once every 3 seconds. So I'm going to go over here and click on this to show you that point. And sure enough, when we get to a time of t equals 3, it repeats itself. And likewise, I can go over here, and so every 3 seconds, this function repeats itself. And we actually had to write 2 pi divided by 3 times t. So the whole purpose of this this coefficient here, omega, is in a sense to squish or to stretch our parent function being a cosine of t, and if we want to squish it so that it repeats once every 3 seconds instead of once every 2 pi seconds, then we need to add a coefficient to make it squish. What if I wanted this period to be 0.5 seconds instead? Well, I would change this to 0.5, and oh my gosh, look at that, it's really squished now, but you can see that every 0.5 seconds it repeats itself. 0.5, 1, 1.5, 2, 2.53. All right. Okay, so let's change back to 3 so that it repeats once every 3 seconds. And now let's introduce a constant that we add to that. So let's take omega times t and then add a phase shift to it. Now let me do a little bit of changing up here. So let's hide the, oops, let's change this to a dashed line. And we're done with that, and we'll hide this. So if I add this constant plus pi over 2, and by the way there's a parenthesis over here, so we're taking omega t plus phi, phi being the phase shift, and then we're taking the cosine of that entire thing. So really, there you go. It has all of that in parentheses. And then if I plot that, what you'll notice is that everything shifted over by a value of, it actually is 3 over 4. Okay. But you notice that when we put pi over 2 in here, our cosine function became a negative sine function. If I put negative pi over 2, or minus pi over 2 right here, where I have it in blue, it will now shift toward the right. And so our cosine function now behaves like a sine function. Okay. All right. So that's how you can actually get a cosine function to behave like a sine function. You just subtract pi over 2 from the phase. Or you give it a phase shift of negative pi over 2. That's another way of putting that. Okay, so to recap, omega squished the function so that it repeats once every 3 seconds instead of once every 2 pi. And then this phase shift shifted everything toward the right. And if we shift it by negative pi over 2, then it now behaves like a sine function instead of a cosine function. And the final transformation we can get is that we can stretch this in y, so that instead of going from negative 1 to positive 1, I can get it to go from negative 1.5 to positive 1.5. And I do that by multiplying this entire thing by an amplitude a. So let's do a little bit of switching around here. Let's make this dashed now because we're now moving from that to this. Oh, and I forgot that. Yep. Now, okay, there we go. So now everything inside the parentheses is the same as it was before. But what the amplitude does in front is it now stretches it in the vertical direction. So now you'll notice I'm going from negative 1.5 in y to positive 1.5 in y. Okay. Everything else is the same. Notice that the zeros didn't change. They're all the same as they were before. But what I'm doing is I'm stretching the maximum displacement and the minimum displacement. If I wanted it to go from negative 0.5 to positive 0.5, I could change this coefficient to 0.5, and sure enough, it shrinks down so that its maximum is 0.5 and its minimum is negative 0.5. Okay, so now you get an idea of why this number out here is the amplitude. You also get an idea of why this number is a phase shift, and it actually shifts everything horizontally. And you also get an idea of why this angular frequency controls the number of radians that we cover every second of time. Or it controls the period, or it controls the frequency of the harmonic motion. Okay, I hope this gives you a little bit better sense of how this function is behaving and what all these variables actually do to the function. And I hope you can use that to figure out some of the problems for lesson 9.1. Good luck. Bye.